Yay, so section 4.4, we're going to continue our work with logs, and in particular, we're going to work with the properties of logarithms. So on page 354, you'll find some basic rules for logarithms, your product rule, your quotient rule, your power rule. And then I've given you some bonus properties for logarithms as well. We'll fill those in just a minute. But for now, let's just try and understand some of these rules. The reason for these rules and the use of these rules is so that we're going to be able to solve logarithmic and exponential equations in the next section. But right now, what we need to do is we need to practice with these rules and come to understand them. Now, let's fill in some of these other ones, these kind of bonus rules together. So the first one was log base b of b. Remember what you're looking for when you look for the log of something. You're looking for what power of this gives me this. So in particular, what power of b gives me b. B to the first power. How about what power of b gives me 1? 0. B to the 0 power equals 1. And this one almost seems circular in reasoning. What power of b gives me b to the x power? X. And we can actually show that one using our properties of logs up here. Now, what this is showing is that the exponential function and the logarithm are inverses of each other. So what you're seeing there is kind of like what you would see if you took the cube root of x cubed. These two operations cancel. You just get back to where you started. So, likewise over here, again, you're doing a function and its inverse. So the exponential function and the log function are inverses. So that would also be an x. And these are some good ones to have. If you're afraid of that you're going to forget these things, a good test-taking strategy is to write them down on the top of your test, right when you get them. And you're like, okay, you write them down. That way you won't forget them during the test. Now, we're going to practice mostly these rules here, but certainly knowing these is going to be helpful as well. We'll start with problem number 24. Log base 6 of 7r. 6 of 7r. Now what you should see here when you're looking at this is a product of two things. But when that product is within a logarithm, then you can split it up. This becomes a log base 6 of 7 plus a log base 6 of r. So it's kind of funny that logs have this property. But the reason that they have this property is because they're related to exponents. And I'll just give you a little guide towards your intuition this way. If I multiplied, say, a to the third times a to the fifth, what do you do with the exponents? Add them. And since logs are kind of like the opposite of exponents, or they're certainly related to properties of exponents and functions of exponents, it's not too much of a stretch to believe that the log of a product becomes the sum of the logs. You can kind of see some of that in action if you did the following. If you started out with log of 5, and then did log of 50, and then log of 500, are you starting to see a pattern? Can anyone make a prediction as to the log of 5,000? Yeah, 3.69, etc. So what's going on that we have this? Well, when you're looking at the logs, let's take a look at the log base 5 of 50, for instance. I could think of that as a log. Actually, I shouldn't be doing base 5. I should be doing base 10. Log base 10 of 5 plus a log base 10 of 10. Okay. Now here's where those bonus properties of logarithms help out. What's a log base 10 of 10? It's just 1. So we'll start out with, if you start out with log of 5 and then looked at log of 50, log of 50 is going to be 1 more than the log of 5. Now let's play that game one more time. Log base 10 of 500. Well, keep in mind 500 is 5 times 100. So I'll rewrite this as the log base 10 of 5 plus a log base 10 of 100. What's a log base 10 of 100? What power of 10 gives you 100? 2. So you get log base 10 of 5 plus 2. And then when you have 5,000, it'll be plus 3, plus 4, etc. You can keep on going with this pattern. But it's just kind of a little bit reassuring to understand that, yeah, these properties, I guess they do kind of make sense. Now let's continue practicing with our properties of logs. Problem number 26. I'm going to kind of jump to the happy ending right away. It's just log, well, actually in this case it's base 5 of 4 times s times t. Okay. Well, this is a log of a product. And what happens with the log of a product, it becomes the sum of the logs. Now, perhaps I should demonstrate how this all plays out, but you know what? Let's just jump, like I said, to the happy ending. Because when you have the log of a product, it becomes the sum of the logs. So let's just jump straight to this part. Log of 4 plus log of s plus log of t, all base 5. Okay. So, time to practice some different properties of logs. Log of the square root of t to the 5th. What base logarithm is understood to be here, even though it's not written? 10. It's understood to be base 10. I'm not sure we really need that. Oh, wait a minute. Did I forget to give you the property of logs that deals with square roots? Oh, that's because there isn't one. All right. But what do we have? We have a power rule, and that's what we need to use here. So the big question is, who remembers their properties of exponents? How can I write this as a power, t to some power? Yeah, kind of keep in mind that it's not really understood, or it's not really written, but it's understood that there's a 2 out in front, right? So, Winston, I think you mentioned that one. T to what power? Perfect. T to the 5 over 2 power. Yay. So whenever you're working with your exponents here and logs, you're going to have to rewrite that rewrite to radicals using exponents. And now, I kind of always think of this as the parachute clause. Something that every good corporate CEO has is a parachute clause. Like when times are tough, like, okay, I can retire. I'll just jump out front. We'll parachute out front. And that's what's going to happen with the 5 halves. So that 5 halves comes out in front. Let's keep going. Kind of blend a couple here together. Are we okay with these first handful of examples? Let's try problem number 32. Log base 3 of x times the square root of y. Where would you start? What are you seeing first, or where do you want to start? All right, good. So Sarur suggests that we write this as y to the power of 1/2. That's good. Can I bring that 1/2 out in front? Not yet. I like that. Not yet. We will, but not yet. Why not yet? What are we going to do first? Got to use our product rule first. product rule for logs, that is. Now that 1/2 can come out front. Because before, if I took it out front, that would mean that I'm applying it to the whole thing. But that 1/2 only applies to the y, and that 1/2 should only be in front of the y logarithm. So 1/2 log base 3 of y. Good on that one? Yes. From the square root. So this is understood to be a 2. That's understood to be a 1. And I rewrote it using exponents. So this one comes up, that one comes over underneath. We did the same thing just a moment ago. We had t to the square root of t to the 5th power. The 5 goes up, the 2 comes underneath it. So that's how we get from one to the other. Okay? Anything else on 32? Let's keep going with, let's see, problem number 36. Log base 2 of s to the 5th over 7t squared. Can I bring the 5 out in front? Not yet. Not yet. There's another rule that I have to use first. What rule is it that I have to use first? Quotient rule. Yeah, because the big thing that you see when you look at this is a quotient. So let's break it up using the quotient rule. And that becomes log base 2 of s to the 5th minus log base 2 of 7t squared. All right, so a couple things I can do here. What are you seeing when you look at this one? All right, so that would be the product rule, right? Now, let's see if you can catch my mistake here as I use the product rule. Also, at the same time, how about if I use the parachute rule for the first term, right? I can bring that 5 out in front. 5 log base 2 of s minus log base 2 of 7 plus log base 2 of t squared. Good job. You need parentheses. So the subtle thing here, and it's annoying, but you got to deal with it. Let's say I put this in parentheses, and I'm going to expand that. When I expand that, I get this. But without the parentheses, the first term is negative, but the second term is positive. That negative needs to distribute itself to both terms. So one way or another, you're going to have to be careful. This is fine, written with parentheses like this, or log base 2 of s minus log base 2 of 7 minus log base 2 of t squared. Actually, I should probably take that 2 out in front, right? So 2 log base 2 of t. That would be a good final answer. I'd accept it in parentheses as well. Just bring the 2 out in front from the exponent. Basically, you're all done with these problems in terms of expanding them when these rules for logarithms no longer apply. That is, you no longer have any quotients, products, or powers, and nothing special down here as well. How are we looking on problem 36? Okay. Let's keep going then. Let's try problem number 38. In fact, maybe I should have you try problem number 38. So 38 would be the log of y cubed over the square root of 2x. So give that one a shot. So what rule should we use to start out with? Quotient rule. Good. So let's start out with log of y cubed minus log of the square root of 2x. We can do a couple things at this step. First of all, the 3 comes out in front. But what else do you think I should do? Good, it's 2x, the whole thing to the 1/2 power, right? So it's kind of parentheses around the 2x, the whole thing to the 1/2 power. And then as before, that exponent comes out in front, so that gives me 3 log of y minus 1/2 log of 2x. And here again, this is one of these places where you got to be careful, because as we expand this, we want to make sure that we don't lose the 1/2. So it's 3 log of y minus 1/2 log of 2 plus 1/2 log of x. But if you don't write parentheses, then you either need to, need to do one of two things. Parenthesis there so that 1/2 distributes itself, or just distribute it and write it next to both terms. So 3 log of y minus 1/2 log of 2 minus 1/2 log of x. Either of these last two forms is okay. All right, it doesn't matter to me which, but just be careful with that 1/2 because it does distribute itself to both terms. And kind of a heads up, I do tend to test you on that. I do tend to look to see, are you being careful with that 1/2? Are you distributing it to both terms? Okay. Getting more comfortable with these properties of logs. There's two more that I want to do here. We'll start with problem number 42. Nothing else on 38, though. Looking good there? Mr. Bryan? Good? Yes. The square root. So, square root of 2x. Just like before, we did here, square root of y. This is a 2 out in front, and y to the first power. Reva, was that a hand? No? Yeah. Well, the negative got distributed in both cases here. So the negative, I didn't have a 1/2 out in front here. All I had was a negative, and that had to get distributed to both terms. So you could either, and technically, I guess we'd write it. The 2 comes out in front, so you can write it one of these two ways, right? That 1/2 multiplies this log, so when you expand that log, it has to multiply both parts, or you can distribute it. So I would accept either of these answers, this one or this one would be an acceptable answer. Just be careful that 1/2 is associated with both terms. All right. Thank you. I want to do problem number 42 because there's something that a lot of people want to do on this one that just doesn't work. In fact, I think we're going to modify problem number 42 a little bit. So, call this problem 42-ish. All right, it's not exactly problem 42. It's what the author meant to do, but there's a typo, I'm sure. It's a much better problem this way. So log of the cube root of x cubed plus 8. Now I chose this deliberately because it just looks so tempting. It looks like you should be able to say, oh, well, that's the log of x plus 2, right? Cube root of x cubed and cube root of 8, except it doesn't work that way. Sorry. You can't do that. You can't split up a square root or a cube root across an addition or subtraction. It just doesn't work that way. So what can I do then? Well, kind of what we've been doing all along. And that is, I'm going to rewrite this. to make it easier to rewrite, I'm just going to put parentheses around this and write in my own exponent, a 1. I haven't changed anything, have I? I mean, something in the first power is just itself, so we're okay there. But now, it might make it a little bit easier to rewrite this using exponents. X cubed plus 8 to what power? 1/3. I hope you're getting comfortable with that. This exponent goes up, that one comes underneath. So this to the 1/3. Then what? Riley? What do I do next? Contessa? Yeah. Our power rule. 1/3 comes out in front. Is there anything else I can do? Let's do a quick inventory. In that list of rules that I gave you, was there a rule for something to do with sums? The log of a sum? No. It's kind of an imaginary rule. A lot of people would like there to be, log of A plus B equals log of A plus log of B. But it's not true. It just doesn't happen. You can't take the log of a sum and turn it into the sum of the logs. It just doesn't work that way. So, is it okay if I do one of your homework problems? You're sure with that? Okay. I don't want to get in my student evaluations. Man, I hated it. You always did our homework. Ugh. All right. So, let's take a look at problem 47. Save you a little sweat in the homework then. And we'll do it together. So, 47 log of the square root of x squared plus 4 over x squared plus 1 times x cubed minus 7 squared. Wow. A lot going on. All right, so all of a sudden they're happy that I'm doing one of their homework problems. All right, this is good. Where should we start? You don't tell me exactly what to do, but just give me a little guide, a little nudge in the right direction, where we're going to go. All right, make it to the power of 1/2. Good. So all of this, when you have these square roots or cube roots or whatever roots, start by making them rational exponents. Now, it's not written, but Contessa, what number is understood to be out in front here? 2. All right, so that's log of x squared plus 4 over x squared plus 1 times x cubed minus 7 squared, all raised to the 1/2 power. Good. Now what? All right, our power rule, right? The parachute rule. That 1/2 comes out in front. 1/2 log of x squared plus 4 over x squared plus 1 times x cubed minus 7 squared. Good. Let's keep going. What other rules can I use? Yeah, good. Quotient rule is what we should be using next. So, 1/2 log of the numerator, which is x squared plus 4, minus log of the denominator, which is lengthy, but it is what it is. Good question. I was wondering if someone would spot that. That 1/2 multiplies all this. So we can either distribute it or we can just leave it in parentheses out in front. I'm for just leaving it out in front and keeping the parentheses. Actually, I do brackets, but same thing. Let's work with this term. So it's going to be 1/2. I'll put in my brackets in just a second. What's going to happen here? What rule should I use? Product rule. Good. And let me give you a little heads up. The product rule, we're going to need parentheses around that. So this is becoming quite nested. Will be the parlance from computer science. So here, get that negative. That's going to be the log of x squared plus 1 plus log of x cubed minus 7 squared, parenthesis for that one, bracket for the rest of it. Yep. So the 2 comes out in front. Now, I'm doing this bit by bit so I don't lose people. But if you wanted on a test, if you wanted to do 2 things at once, you say, okay, I know I'm going to need the product rule, and I'm going to bring this down at the same time, that's fine. You don't have to show me every little step. That's okay. All right, 2 questions, Contessa? You know what? Let's see, it was, yeah, thank you. That should be a squared. Thank you. Okay. Let's bring the 2 out in front. It's going to be 1/2 log of x squared plus 4 minus log of x squared plus 1 plus 2 times the log of x cubed minus 7. Let's put in all the right notation here. There. And here. You can leave it like this. That's fine. If you wanted to, you could distribute everything. Here I need to distribute the negative to both terms, and here I'd have to distribute the 1/2 to everything. So another alternative would be 1/2 log of x squared plus 4 minus 1/2 log of x squared plus 1 minus, because that minus distributes, 1/2 times 2 is going to be just a 1, so this is going to be minus log of x cubed minus 7. So either of these 2 last lines would be acceptable to me as a solution. Yay. How are we looking on that one? All right. Okay. Let's work a couple in the opposite. Well, let's see, a couple more just to practice with these things. Now, look, these problems by themselves are not like directly applied. It's not like these are the solutions to equations in quantum physics, but they are good applied problems, or they are good practice problems for what comes next. So it's laying the groundwork. It's not what we're doing now that's really fun and interesting. It's what's coming after this that's going to be good. Let's see if we can evaluate a few of these things without a calculator. And we'll start with log base 3 of 135 minus log base 3 of 45. So the challenge is to use our rules in the opposite direction. So when I have the difference of 2 logs, then well, that can be written as a quotient. So I'm combining things. Instead of expanding things, we're combining things. So it looks like this. But this is a little bit, or it can be written a little bit easier. 45 goes into 135 exactly how many times? 3. And can someone evaluate this one without taking advantage of their calculator? 1. Good. Equals a 1. Nice. Done. So this is the reverse of what we were just doing. By the way, what we were just doing is called expanding the logarithm. And urban legend has it that somebody was given a problem to expand the logarithm. Expand this logarithm. Now, generally what's expected is the kind of stuff we were doing here, where you start out and you start using all your rules, and that's expanding the logarithm. But urban legend has it that on a test, when they're asked to expand a logarithm, the student wrote this, and then this, and finally this. All right. That might get you a point for humor, but I'm not sure it's going to get you full credit if you expand the logarithm like this. Okay. Let's take a look at another one kind of like that previous one, maybe one or two. Problem number 16. Log base 5 of 1 over the square root of 125. I'm not sure, maybe it's just because I'm speaking this, but I wrote the 2 out there, which I don't really need to do, right? It's kind of understood. So, oh well. Let's see if we can evaluate this without the use of a calculator. So, maybe we'll expand this one in the correct way. Log base 5 of 1 minus log base 5 of the square root of 125. Okay. Well, let's work with the square root a little bit. Log base 5 of 1 minus log base 5 of 125 to the what power? 1/2. Thank you. And that 1/2 comes out in front. And what's left should be something that maybe we can work with. So it's going to be log base 5 of 1 minus 1/2 log base 5 of 125. I think we got it to a point where we can really dig our teeth into this. Let's start out with log base 5 of 1. What power of 5 gives me 1? 0. All right, awesome. I'm not sure my audience at home can appreciate that, but everybody said 0. It was really cool. How about over here? What power of 5 gives me 125? 3. And so I get minus 1/2 times 3. The 0 doesn't do anything, so it's just 0 minus 3/2, or better yet, minus 3/2. Yay. Now, for those of you who are not really good at doing these square roots and cube roots and stuff like that, or working with these logarithms, let me try to help you out a little bit. All right. It'd be nice if we could do this on our calculator. But on your calculator, what bases do you have built into the front of your calculator? I'll give you a hint. There's 2 of them. You can directly calculate log base 10 and log base e. Now, kind of a nice thing, if you get confused as to which one's which, or you mess up the notation, take a look at what's right above the log key. If you hit the second key to shift up, what function are you going to get? 10 to the power. That's because they put the function and its inverse on the same kind of key. Same thing here. ln of x and e to the x. So log goes with base 10, ln goes with base e. Those are the 2 that are built into the face of your calculator. But if you're borrowing one of my calculators, it doesn't work on the 83, sorry. But if you're borrowing one of my calculators, then you can calculate log to any base without using the formula. Now the formula, log base b of x, this is your change of base formula. Change of base. So log base b of x is the log of x over the log of b. So it's nice that you can change things up. You can change, you can do a different formula for calculating some of these things. So, for instance, suppose I'm looking at this, I'm like, you know, it probably works out something good, but I just can't figure out the log base 6 of 7,776 in my head. So, example. Log base 6 of 7776. Well, if you're stuck on the test and you just don't know how to do this, then you can do this. Log of 7776 divided by log of 6. Log of the number divided by the log of the base. And let's see what happens if we do this. So log of 7776, right parenthesis, you got to close off that term, divided by log of 6. 5. Oh, okay. So let me check that. Because what that's saying is that 6 to the 5th power should give me this. So let me check that. 6 raised to the 5th. Oh, okay. It works. Nice. I feel like one of those infomercials here. But wait, there's more. All right. Here's the cool part. If you have the TI-84 and your operating system's up to date, we can do this another way. Hit the math key. And if you cursor up, it's probably the faster way to get there. You should see this option next to the A. It says log base. Press that, and now you can type in a 6 here for the base, and 7,776 right here. Ooh, I want some love on this one, man. This is cool. All right, if this was like a Math 1150 class, I wouldn't be showing this till much later. But I'm showing this to you now, so that's cool. All right, so nice. Now, what's that do for us over here then? Can I do this one? Let's see. Negative 3/2 should be negative 1.5 as a decimal. So let's try the math key up here. Log base 5 of 1 divided by the square root of 125. Bam. Negative 1.5. Booyah. Nailed it. So you don't have to worry about being a human calculator when you're presented with these problems. It's not going to be a big deal for you. Just use your calculator. Okay. Looking good with change of base formula. I will give you the change of base formula on the test if I think you need it. I mean, some of you may need it, some of you may not. But regardless, you should be able to calculate log of any base, all right, with either the formula or direct commands on your calculator. So that is something that I expect. Let's continue working with things the way we did up here with problem number 12. That we're putting things back together as to one term. So we'll start with number 50. Let me actually read the instructions here to you. It says, use the laws of logarithms to combine the expressions. Okay. Well, let's see. 1/2 log base 2 of 5 minus 2 log base 2 of 7. What I would do first, personally, is I'd use my power rule in the opposite direction. So if I use the power rule in the opposite direction, then what we've been used to is we expanded the logarithms. I'm going to get log base 2 of 5 to the 1/2. And I guess it's up to you if you wanted to take the -2 or just the 2. Let me take just the 2. So minus log base 2 of 7 squared. Now let's rewrite this a little bit. What's another way I can write log base 2 of 5 to the 1/2 power? Square root of 5. All right. Square root of 5. Cam, help me out here. What's another way I could write 7 squared? Perfect. 49. And now I've got one last thing to cover, and that is I got to figure out how can I rewrite a log of something minus a log of something else. What brings those together? Well, our quotient rule. Our quotient rule. So when I have the difference of logs, I can write that as the log of the quotient. What's going to go in the numerator? Square root of 5. Good. Over 49. And that's it. Okay. And one of the things I like to emphasize for us when we do these things kind of goes back to a previous example. If you have the sum of logarithmic terms, log of this plus log of this plus log of this, all the same base, then I can bring that together as the log of a product. So the sum of the logs becomes the log of a product. So we're going to do things this way. And give me a second on this next one. It's not an example in your book, but let's see what you can do with it. All right. See what you can do with this one. It's an I here. I and then a plus. C, A, B, I, and N. All right. I should see some laughter. You guys should be falling on the floor laughing. All right. Someone explain it to Madalena. Log of what? Log cabin. Come on. There's not too many math jokes I can build into the lecture. Give me a little love on this one. All right. Log cabin. Yay. All right. But nonetheless, it does show you a nice little property of logs, and we brought all this together to get log cabin. We're going to kind of build on that. Let's see. I think it's problem, call it 56 prime. Problem 56-ish. So it's going to be 2 times log base 5 of x minus 2 times log base 5 of y minus 3 times a log base 5 of z. So again, we want to bring this all together with one term. Now, I'm going to do this a little bit different than some of my colleagues might, but I think it's going to be more efficient for you. I think it's going to get you to the right answer faster. I'm going to start by distributing the 2 to all 3 parts of this. So 2 log base 5 of x minus 4 log base 5 of y minus 6 log base 5 of z. Before I use any of my power rules or quotient rules, I shouldn't say product rule or quotient rule, before I use those, I got to get rid of the coefficients. And here's where I'm going to do something a little different than a lot of my colleagues. Here I'll bring up the 2, so log base 5 of x squared. But here, in addition to bringing up the 4, I'm also going to bring up the negative. So it's going to become plus log base 5 of y to what power? Negative 4. Plus. So I'm getting rid of the negative and the 4. And likewise here, I'm going to get rid of the negative and the 6. Log base 5 of z to what power? Negative 6. Now here's where we can use our little log cabin rule, right? You've got the sum of the logs. There's no more minuses. We don't have to worry about that. So this becomes the log of a product. And this is where it becomes nice and efficient. Because if you do it other ways, it's just a real nightmare to work with all these negatives and work with the quotient rule repeatedly. It's a pain. So this is pretty good. Log of all this. But there's one last thing I'm going to ask of you. And usually I don't bother with this, but on these problems I will. I want us to get rid of the negative exponents. How could I get rid of the negative exponents here? So these terms go to the denominator, and they become positive exponents. X squared over y to the 4th and z to the 6th. So, voila. But I guarantee this is a lot easier than messing around with all kinds of quotient rules. Because you have to use the quotient rule at least once, maybe twice, depending on how you do it. Take a little more skill and insight. This is nice and direct. Okay. How are we looking on 56? All right, for homework. Bless you. Try problems 9 through 63.